So there is essentially an algorithm. And the algorithm is, whenever you arrive at a physical contradiction, you go in this sequence. You start with separation in space. Problem is solved. Great. Think of ideas. Not solved. Okay. Go to time. Go to relation. Go to system, subsystem level. Still not solved. Then look if you can satisfy the contradictory demands. Still not solved. Then look at bypassing the contradictory demands. Okay. Do you realize bypassing, why are you putting bypassing the contradictory demands in the end? And why do we not start with that?
Because so we need to think like in a different paradigm for that. And in the
What?
previous cases, we can just like, so it is easier to just find solutions for these separations, space, time, relation, system level, comparatively easier.
So talk about frogs. So in that frogs and elephant experiment, were you more of a frog or more of an elephant, or somewhere in between?
So I was, I think, around 18 or something.
Yeah, so
So
somewhere in between, huh?
yeah, yeah.
So look at the frogs. They will come up with the levitation, or they will come up with contradictory demands while our solutions very fast.
Hmm.
So it's
Yes.
not about difficult to think of a solution there. Something
Okay.
else. Why would you want to keep it in the end only, not in the first?
Probably because it would require major system changes, which would lead.
Yes, it is a disruptive idea. Paradigm shift, complete change in paradigm of how to solve the problem. It's a major disruptive idea, and you would need to rebuild the entire systems. Even though there is a solution, it will take a lot of time to make it running. So while China has made this train at 600 km per hour, the thing is that they need to also make the track now. Train bana lena and track. Now, implementation means now you need to completely rebuild the entire track. 1500 kilometers का track banana padega, and it's not simple. It takes time and energy and resources. It cannot run on the same tracks that existed. Whereas if you were separating in space or in time, you do not need to change the super system at all. Are you able to see this? So ideas that would originate from the first 4 or 5 things would be simpler, much easier to implement, much more acceptable. Bypassing contradictory demands, paradigm shift we are talking about. The answers could be disruptive, or would usually be disruptive. Therefore, it will take time to implement. But it will happen. It will happen. No one is saying these are bad ideas. They will happen. But when you are suppose doing a startup, or when you are doing working in a MNC or anywhere, do you want to do R&D while solving a problem? See, you have a problem at hand. Solve it, na? That is the need of the hour. R&D, okay. For R&D, generate ideas by bypassing contradictory demands. But for now, solve the problem. Then we will initiate an R&D project also. Are you able to see this? The importance of following this sequence, why this comes in the end and separation principles come in the top. Any questions about that? Okay, great. So with that, in fact, okay, so this was the example of the SRAM that we had taken. Do you want me to explain it? Basically the same example that we had in the last class, where we said that if we separated in space and time both, we were able to come up with a solution which was denser and also better in terms of functionality and this. So I have put in this example just to say that you should, as designers, ask questions as, should I separate only in space, or can I separate also in time, or can I separate also in relation, for example? And then as you ask yourself more questions, you may be able to come up with better answers there. Okay.